Bismillahirrahmanirrahim. Assalamu alaikum. Hope so you all will be fine. Today we are going to talk about degenerate perturbation theory. So if we two states are degenerate, which means that the energy in R is associated with psi of A naught plus B psi of B naught is same. Then A naught is equal to E B naught is equal to E naught. So in case of degeneracy, the energy associated with this state psi A and psi B, this will be same. So if we look toward the first order correction in wave function formula, then we will see that here it is. So these two energy EA and EB, these two will be equal, and this denominator term will goes to 0, and this whole thing will be undefined. So for degenerate states, ordinary perturbation theory fails, and we have to develop something new to discuss this perturbation in degenerate state, or in the case of degeneracy. Let us say that H naught, it is an operator which is applied on this state, and it gives us this energy state. Also, if we talk about this thing, this will be something like this. So, and as we know that by the definition of this inner product, we have psi of A and psi of B. Their product will be equal to 0. It is actually equal to delta ij. In this case, I is not equal to j, so this is equal to 0. A linear combination of psi A naught and psi B naught will also be the eigenstate of H naught with the same eigenvalue E naught. So let us take this function. Let's psi naught is equal to alpha into psi A naught plus beta into psi B naught, and H naught, which is applied on psi naught, is equal to E naught into psi naught. Okay, so this is actually the thing which we have written over here, that the linear combination of these two functions will also give us the eigen value or eigen functions equal to A naught, which will be the same. Okay, so let us start our calculation with our newly defined function psi naught. As we have defined this psi naught in this way, so we will calculate by using this psi. Define psi naught. So H into psi naught is equal to E into psi naught. So H is equal to H naught plus lambda into H bar, and E is equal to E naught plus lambda into E1 plus lambda 2 into E2. So these three are basically the definitions of H, the Hamiltonian, along with the energy E. This is actually the definition of energy, which is actually the linear combination of all those energies which are energy eigenvalues which are formed, or which in case of perturbation, or after applying the perturbation. So this is the wave function psi naught, psi 1, psi 2, along with these lambdas. Put all these into equation 1. We will put all these values which we have defined over here in equation number 1, which is this thing. So we will end up with something like this. When we will multiply these all these values, we will get this whole thing, and after that, as H naught and psi naught is equal to E naught psi naught, so first term will cancel out this term and this term, as though both these terms are equal, so we will cancel these two terms. After that, we will left with this term, and on the right hand side it is yes, this term. Now we'll have to take the inner product of this equation with psi A of 0, or psi A naught, whatever you would like to call it. Here we have taken that inner product, and the term this term, and on the right hand side this term, these will cancel each other due to the h, because h naught is the Hermitian. This thing we have already done in one of our previous homework, so you can concern those nodes for its solution, and you can prove that these two terms are equal and they will be cancelled. They will cancel each with each other, and then we will left with this term and this term over here. And now we are going to put the value of psi naught in this equation. So here is the value of psi naught, which we have already defined above. So after putting that, it will become something like this. So here is actually the value of that psi naught, which we have put over here. Okay, after a little simplification, we will end up just we are over here we are just simplifying or writing this thing in some other way, like this. So here it is alpha, and this is h bar, something like this. This is h with beta. We have taken beta out over here, alpha out over here, and this is the whole thing. Okay, now if we look on right hand side, here is your E naught along with this alpha plus E1 along with beta. So this thing, actually these are two different states, so this will cancel each other with each other. Here it will be equal to 1. We have put that 1 over here, as this is the inner product, and it is actually the definition of this inner product, that if these two states will be the same, then it will give us 1, while if these two states are different, it will give us 0. So this is over here. If we examine this whole thing, so this term, this thing psi a of 0, h bar, and psi a of 0, this whole thing, this product can be written like WAA. So these A are basically we have taken from over here, from here, psi A and psi A. So this is psi AA. Also this thing is psi AB. This is actually psi AB, and we have written it like WAB, just for sake of simplicity. So now we have written this whole equation in this form in term of WA and WB AB, which is equal to E1 alpha. In the same way, if we take inner product with psi b of 0, then we have taken the inner product over here with this equation with psi a of 0, and then if we take the inner product with psi b of 0, then we will end up with this equation. As in case of psi a of 0, we have ended up with this equation. So in case of psi b of 0, we will end up with this equation. It's your homework as an assignment. You will do this. Same calculation will be over here. Okay, so these are two equations, and we have written these two equations in terms of form of matrix form. So we are so W's are the matrices elements. So these WA, WB, these are the matrix elements. We have just written this thing over here in respect to the perturbed wave function W and V. Okay, from this equation, from equation number steric as an assignment. So this is actually your assignment. From this equation, we have actually made this equation. How this is valid, or this whole thing, this equation is equal to this equation. This is your assignment. You will do that, and after that, if we take this equation, then this equation will have trivial solution only if this will only have the trivial solution if it satisfies this whole thing. So if its determinant is equal to 0, then this will have some trivial solution. Solving this determinant, we will have this equation, and after a little simplification for the value of E1, we will have this whole thing. Okay, so this is a little simplification. You can do this as your homework or for your practice, and you will end up with this equation, which is actually the E1, and it have actually two values. If we are will look carefully over here, it is plus minus, so it will have two values, and it is actually refers to the twofold degeneracy. Okay, where WAB is equal to WBA static. This is fundamental result of degenerate perturbation theory for two roots are to and the two perturbed energies. So this is actually the solution for the energy first order correction in energy. Show that for WAB equal to 0, the energy correction will be like that of non-degenerate perturbation theory. Again, something for you, that let us say that WAB is equal to 0. So put WAB equal to 0 in this equation, and find out that it will become the energy relation for the non-degenerate perturbation theory. So this is again, this proof is your assignment, and in next lecture we will move forward. Thank you so much.